Good morning, guys, and welcome to today's video on GCSE exam style questions, part 1. Right, guys, this video was filmed on Saturday, the 18th of July 2020. Right, guys, if you're new, welcome. My name is Abdallah Wahishi, and I'm a private maths tutor and a recently qualified maths teacher for secondary and primary. I make videos on Key Stage 1, Key Stage 2, Key Stage 3, GCSE and A-level maths, as well as further maths and some undergraduate level maths. Please do subscribe to my channel, drop it a like, enable notifications by pressing the bell icon. Okay, but let's get on with today's video. Okay, right, guys, today's video actually, obviously is a slightly different video actually. What I've done actually is I've made like a little revision list actually of topics that I'm going to be covering. Okay, so the plan for today, is that so this is like a two-part series actually. So the next part will come out on Sunday, the 19th of July, 2020. Okay, and the plan today is I'll be covering topics here. Obviously, since I actually started my channel actually back in November, or October, sorry, last year. Okay, because obviously some people are like new subscribers, so it's important obviously to obviously keep you guys updated and in the loop. Okay, so it is aimed at GCSE and IGCSE maths actually. Okay, at the end, guys, I'll be putting like a little link actually, so two links. Okay, for GCSE maths actually. So so obviously click on those links and have a go at those questions. Okay, because they will show like exam style questions. Right, guys, first topic here is indices. Okay, so question 1 says find the value of 9 to the power of 0. Okay, so anything to the power of 0, guys, is always going to be 1. Okay, so that is always my rule. Okay, anything to the power of 0 is always 1, apart from 0 to the power of 0. Okay, that's the only one that is actually undefined. Okay, but x to the power of 0 is 1, a billion to the power of 0 is 1, minus 1 to the power of 0 is 1. Anything to the power of 0 is always going to give me 1 as my answer. Okay, right, evaluate 10 to the power of 4. 10 to the power of 4 means 10 times 10 times 10 times 10, which is 10,000. Okay, question 3, 2 to the minus 3 means 1 over 2 cubed, which is 1 over 8. Okay, so it's 1/8 or 0.125. So this topic is what I call, negative indices. So this is obviously, indices, obviously, power of 0 and that actually, okay? Right, question 4. X to the power of 2 times x to the power of 3 is x to 2 plus 3. Okay, so I add my powers. Okay, and then I get x to the power of 5. Okay, as my answer. Right, next one. Work out y to the power of 10 divided by y to the power of 5. Okay, so what I do here is I subtract my powers. So it's 10 minus 5 is equal to 5. Okay, so the bases have to be the same actually. So the letters must be the same actually for me to either add or take away actually, depending on what I'm doing operation wise. So if I'm timesing, I add my powers. If I'm dividing, I subtract. But the bases, so the letters or numbers must be the same for both. Okay, there is no rule for adding or subtracting powers. So so for example, if I had 3 squared plus 3 cubed, okay, there is no rule actually, for that actually, and conversely, there is no rule, for example, 7 cubed minus 7 to the power of 2. Okay, so the rules are only for timesing and dividing actually, for indices. Right, guys, more questions. Okay, so it's grade 4 and 5 actually that I'm looking at. Okay, so x to the power of 4 all cubed. Okay, so when I have a bracket here and it's raised to a power, then what I do is I multiply my powers together. Okay, so another rule, guys. Okay, so rule 3. Okay, so so if it's a bracket and then it's to a power, I'll multiply my powers. So 4 times 3 is 12. Okay, so x power of 12. Right, guys, question 7. 10 to the minus 1 times 8 cubed. Okay, so 10 to the minus 1 means 1 over 10, or 1 over 10 to the power of 1, which is going to be 1 over 10, times 8 cubed actually. So it should be, I've made a mistake. It should be 8 squared actually, not 8 cubed. Okay, so it should be 8 squared. Okay, so 8 squared is 64. So I get 64 over 10, which is 32 over 5, which is 6 2/5 or 6.4. Okay, so it should be 4 sorry, it should be 8 squared actually, not 8 cubed actually. It should be 8 squared. Okay, right, question 8, guys. Simplify 3x to the minus 9 times 2x to the minus 7, all divided by 7x to the power 10. Okay, so what I'm going to do is 3 times 2 is 6, x to the minus 9 times x to the minus 7, so I would add my powers. So it's minus 7, add minus 9, add minus 7, becomes minus 9 minus 7, which is going to be minus 16, divided by 7x to the power of 10, which will give me 6 over 7x to the power of minus 26, guys. Okay? Right, guys, question 9. Simplify xy squared times x squared y cubed. Okay, so again, multiply my powers. Okay, so x times x squared is x cubed. Y squared times y cubed is y to the power of 5, using the laws of indices. Okay, right, guys, question 10. Simplify fully 2p squared times p to the minus 1, q to the minus 1. So adding my powers, I get 2p to the power of 0, q to the power of 1, because it's p, so obviously p to the power of 1 actually, so it's 1 minus 1, which is going to be 0. Q squared times q to the minus 1 becomes q to the power of 1, because adding my powers, 2 add minus 1 is going to be plus 1. Okay, so my answer is just 2q. Right, guys, fractions actually. Okay, so next part, fractions. So it's grade 3, 4 actually. Okay, so multiplying fractions. Right, guys, when I multiply fractions actually, all I do is multiply my numerators together and my denominators together, and then that's it. Okay, and then simplify where possible. Okay, so 2/3 times 4/5. 2 times 4 is 8. 3 times 5 is 15. So my answer is 8/15. Okay, right, guys. Example 2. Work out 10 over 7 times 8 over 9. Again, 10 times 8 is 80, 7 times 9 is 63. So obviously that is an improper fraction or a top heavy, okay, which is 1 in 17 over 63 actually as my answer. Right, guys, next one. Work out 1 2/3 times 3 2/9. Okay, so multiply mixed numbers, guys. Okay, there are more than one way actually to do actually, but the way I taught it actually. So if you multiply by a mixed number, you will convert it to an improper fraction first, and then multiply it as usual. So 1 2/3 as an improper fraction is 5/3, and then 3 2/9 as an improper fraction is 29 over 9. Okay, multiply my answers together. So 5 times 29 is 145. 3 times 9 is 27. Okay, so it's 145 over 27, which as a mixed number gives me 5 and 10 over 27. Okay, so that is actually one way. There is like another way to do actually. Obviously. So there are like multiple ways actually. The other way is that what you would do is that you would multiply like each number by each part of the fraction, if that makes sense. So so that's like another way actually to actually do that. Okay, but stick to it. Like if it's a mixed number, convert it to an improper fraction actually, because it's just obviously nice and easier. Right, guys, next one. Okay, so more fractions actually. Okay, so dividing fractions. Okay, so dividing fractions, guys. So I call it actually the KFC method. So what you do is, so K stands for keep the first fraction. So you keep the first fraction. F stands for flip, so flip the second fraction, and then C means change the divide to a multiply. So you flip the second fraction, change it to a times, and then you would follow the exact same process as multiplying fractions. So you'd get 1 times 2, which is 2, 3 times 1, which is going to be 3, so my answer will be, is 2/3. So a third divided by a half is a third times 2 over 1, which is going to be 2/3. Okay, so you flip the second fraction, keep the first one the same, and then change it to a times. Okay, so example 2. Right. 2/3 divided by 9/7. So it's 2/3 times 7 over 9. Okay, which is 14 over 27. Okay, example 3. 10 over 9 divided by 9 over 5. 10 over 9 times by 5 over 9. 10 times 5 is 15. 9 times 9 is 81. So my answer is going to be 50 over 81. Okay, so this is grade 3, 4, guys. And then lastly, I think I'll put it on there actually. So if you have a mixed number, guys, make sure that you change it to an improper fraction first, and then do the exact same procedure again actually. Whereby you I like to call it the KFC method actually. So it's a nice way to actually remember. So KFC method: keep, flip, change. Right, guys. Okay, so next part, which is surds. Okay, so surds are what I call an unsimplified radical. Okay, so surds just means, yeah, that I'm taking square roots of numbers that give me irrational answers. Okay, so like yeah, like yeah, so it does not give me like a whole number answer. Okay, so root two is a surd. So root two does not give me a whole number. Okay, because because two is not a square number actually, because there are no numbers that I can multiply together to make two. Okay, so that's what a surd essentially means actually. Yeah, so obviously it does actually require your like knowledge on square numbers. Okay, so obviously yeah, obviously one squared is one. Yeah, so like square root of one yeah is not a surd. Root two is a surd. Um, Root 3 is a surd. Root 4 is not a surd actually, because obviously square root of 4 is 2. Root 5 is a surd actually. Root 7 is a surd. Root 9, yeah, is not a surd actually, okay? And also root 6, yeah, is a surd. Okay, so it requires your knowledge on square numbers, guys. Right, guys, rules of surds. Okay, so root A times root B is equal to root A times B, okay, which is equal to root AB, okay? So if I multiply surds together, okay, I can write it as one surd. And then conversely, root A divided by root B will give me root A over B, okay? So I can write it as one fraction under one square root, okay? Right, lastly, guys, simplifying surds. Okay, so some surds actually, yeah, so like such as like root 8, yeah, or like root 32, yeah, or like root 96 actually, yeah, and many more actually can actually be written in like simpler surd form. Okay, so what that means is I can write that, yeah, as like yeah, like a surd actually in its simplest form. Okay, so root 8, yeah, can be written as root 4 times root 2, which can be written as root 4, yeah, times root 2. Root 4 is going to be 2 times root 2 is 2 root 2. So root 8 can be simplified to 2 root 2 in its simplest form. Okay? Right, guys. Okay, so rationalizing the denominator. Okay, so the last part actually for like today's lesson. Okay, let's say I have this surd, so it's simplify 1 over root b. Okay, so when I divide by a surd, guys. Okay, what I want to do actually here is essentially what I call rationalizing the denominator, and what that means is I would multiply top and bottom by that surd actually to essentially get rid of the surd on my denominator, okay? Because obviously dividing by a surd actually yeah, obviously it is quite complicated. Obviously, yeah, when back in the day actually, yeah, obviously when there's no calculators, obviously yeah, it was obviously very difficult to actually divide by a surd. However, obviously this rule allows you to like rationalize it, so you have essentially a number, yeah, on top of a number, or a surd on top of a number actually, yeah, okay, obviously, which is far easier to deal with, yeah, like essentially, yeah, so like when you're working this out, guys, okay, so simplify 1 over root b, so it's going to be 1 over root b times root b over b, okay, so I'm essentially multiplying by 1, and 1 is the same as root b, sorry, okay, yeah, so I get 1 times root b, which is root b times root b gives me b, okay, so it's a little rule there, okay, yeah. Okay, so yeah, so that is the rule actually. So my answer, I get root b over b. Okay, obviously, it does obviously get a bit harder actually. Yeah, so obviously, yeah, I'll be looking at more harder examples actually. Yeah, but if you want actually, you can go back to actually my earlier channels actually, earlier videos. Okay, like yeah, I've made like a video, yeah, for like obviously like harder examples. But the general idea is that you multiply by its conjugate, so by the root of that number. Okay, so if it's 1 over root 2, you would multiply by root 2 over root 2. Okay, yeah, essentially, yeah. Or if it's 1 over root 7, you would multiply whatever the like denominator is, yeah, but obviously by itself. So yeah, obviously, yeah, by that. Okay, so yeah, so I hope that actually made sense, guys. Yeah, I hope it was clear. Yeah, obviously, sorry, yeah, if I was like, actually flying through it actually today, actually, yeah, I hope it was clear. I hope you were able, yeah, to take something away from it. Okay, so yeah, it's just the end of our lesson. Yeah, if you found this useful, guys, yeah, please do drop it a like. To turn on post notifications, yeah, so you guys can be notified when my uploads are. Yeah, feel free, yeah, to obviously comment below any questions or queries. Yeah, and I'm sorry, yeah, for like talking very fast. Actually, apologies for talking quite fast and throwing like a lot of information actually, but don't panic yet. I'll be doing like another one of these hopefully tomorrow. Okay, is my plan. Yeah, and I'll try and cover as many topics that essentially I've covered actually here previously. Okay, so this is like a little like revision video actually here. So like yeah, so you're obviously welcome to actually save it and obviously share it around. Okay, yeah, obviously make sure that you obviously practice actually. Okay, and then lastly important so please do obviously check out these two links. So you got a maths watch link and a copy maths to obviously for you guys to actually practice like lots of questions. And so like comment below here if you actually found this useful here, or you got any tips or queries here, and feel free to give me any feedback on my lesson, guys. Feel free and then please do obviously obviously share it around actually if you find it useful. And obviously comment below any questions or queries or any topics that you'd like me to cover for like next time or next week. Okay, thank you so much for watching, guys. I hope you're all well, and please stay safe, and I hope you are all enjoying your summer safely. Thank you so much for watching, and I will see you tomorrow. Okay, happy Saturday. Bye now.